Hey, hi everyone. I've built a agentic graph-based RAG system, and which what essentially does is extract the unstructured documents into intelligent knowledge graphs, and then which can be used to query via autonomous agents, so that they can extract the relevant data using various query languages like various querying methods like simple semantic search or vector search or graph transversal search or any other logical filtering. So I'll first start with the brief architecture, what I have done and how I have created it. So first I have created different services for different steps that are there in the system. So first is the document ingestion system, where which is the ingestion service, which takes all the documents and parse the text from different files. Currently I have focused on text files, markdown files, for word files and pdf files, and it, but it can be further extended down to various other various other formats like images or any other formats that are there. Then coming to the ontology extraction services, where we extract different kinds of ontologies that present in the data that you have uploaded. Then there is graph construction services, which which extract all the relationships from the different entities and relationship types that are there, and it creates a graph from graph out of the data that we have. Then there is the retrieval service, where you whatever the query that you ask, it extracts intelligently based on the tools or based on the different strategies that are available to the agent itself. So now coming to the actual, I have a good demo. It is I have prepared. It is not currently hosted. I'll try to host it before the competition end, but I'm not sure if that is I will be able to do that. But keep the fingers crossed. So I'll currently log in via my sample user that I have created. This is the home screen where you can see all the things that you can do with the platform itself. And then currently let me take you to the ontology extraction page, where we'll try to extract the ontology for one particular document. And I have created, like, so for this demo I have uploaded a couple of documents, because document processing takes some about 10 minutes, 5 to 10 minutes of time to process one document. So currently I have what I have done is for this particular demo, I've pre-uploaded a document, and also at the same time, I have prepared some small text so that I can show you wherever I can to at every step. So so this is a text that I have sample text that I have made, where it will use GPT-5 and extract all the ontologies that is there in the text itself. Seems like it was finished, but let me quickly go through what are the different ontologies that it will be able to extract. Like, it will extract the entities as well as the relationship types. Entities can be like person or organization or product or something like that. And ontology relationship types would be something like a person leads a company, then leads will be that, or has a role, or a company produces some good, or company has partnered with something or something like that. So uh, so it will extract those kind of ontologies from it. So from the text that you are given, you will be able to extract person, company, research institution, projects, technology concepts, and different, and the relationship types: leads a project, founded, or works at, partner with, or associate, so things like that. So it was able to extract different set of ontologies that was there in the document that we uploaded. Now let me go to the document. Now let me go to the documents page, where you will be able to see all the documents that you have already uploaded. So as I was mentioning, for the demo purposes, for the demo, I have already uploaded 4 documents that was there, which was AI companies, then there was space exploration, then it was tech universities like Stanford, and climate tech, what is happening in the climate tech. And I have extracted this from the Google itself and created a couple of documents and uploaded it. And so what this this document ingestion does is it takes the document, extract the text from that particular document, store it in our vector database, then it passes on to ontology service. Ontology service is what is, as we seen in the demo, it tried to extract the ontologies that are there in our data. Then after this, then it goes to the knowledge graph preparation, where from the ontologies and the text that we have, it will try to map the relationships and the entities and create the graph out of it in our Neo4j instance. So this is how the document processing works. Document processing, the entire process works, and this document processing, if I keep it will take some time, so I'll skip the demo part over here. But yeah, but you can also view the individual documents here, like what are the documents and what is the content in them and stuff like that. So I'm not sure currently, for some reason this is not opening, but you can view these documents over here. Not sure, but yeah, I'll probably look at this why it's not working. We try it one more time, maybe it's opening. Yeah, no, sorry. No worries. Yeah, it opened up gladly. So if you see, this is a basic document type that are there, and what are the chunks, different chunks that was there in the document itself, and you can see it was a big document and it had a lot of chunks. So, and if you can see the number of chunks that are there in the documents, like it was word count was 1,000 words and it has 58 chunks in that. So yeah, this is one of the feature. Then let's go to the knowledge graph screen, where you can see all the graphs and sorry, it is loading. It queries all the data that is there. Then I'll quickly talk about what are the different noise graphics. So if you can, like, for the actual graphs, I did use D3JS, but it's a little it looks a little cluttered, and we are not able to read all the entities and relationships that are there. But for the graphs, I'll take you to the Neo4j screen. But for now, like on this page, you can see the total number of nodes, relationships, nodes type relationships that are there, and you can also filter it by node limit and also any particular entity type. Like if you want to filter by person, what are the persons that are there in your knowledge graph, then you can filter it down by this, and it will give you all the persons or the for that particular entity that is there for that particular entity. If you see, like it's taking some time, not sure why, but yeah, it takes some time to run. Then it so then I'll go to the document, sorry, Neo4j screen. So in the knowledge graph, there are different functionalities to it. Like for example, if I speak about like one particular entity, like Elon Musk, like he was part of his space document as well as the tech data as well. So it was able to map those entities across multiple documents, as well as the it was also able to deduplicate or uniquely map different one entity towards different documents, as well as it is you can also you can also see that it for one particular entity, it like whatever data, like if a person has a role or like it has a role of CEO and chief engineer. If you look at the right part of the screen, left part, yes, right part of the screen, you can see like this relationship has a role is CEO and chief engineer, which may be different for different like this has CEO founded by. So the entities can have different, so relationship types can have different attributes assigned to it. So for example, Elon Musk is a nationality is American. This was present in the data. It has role of founder. Then Sam Altman is this is again, it has a role. Then um, this Fifi Lee has artificial intelligence and it has a role for director at Stanford Intelligence. So every entity is got able to extract, like OpenAI has different product lines, ChatGPT, GPT-4, GPT-5, then Dolly. So it was able to extract all the specific entities, relationship types, and the their as well as the different entities that are there. Like if you see, some are entities. All these are all the entities, and these are persons. Then these are companies. These are products. These are research labs. These are technologies. So it is not only able to extract the entities, but also what kind of entity it is. Now I'll go to the UI itself, where I'll query a couple of I'll mm, do some queries, and I'll explain how the queries work and how how these are like. I'm sorry. Top is hanging a lot. Maybe because. So this is the first query that I'll pick. This is a simple query where it will just, sorry about that. Yeah, this is a simple query like with the C of Microsoft. It's a simple vector search query, and like it will just search for the documents with the relevant information that is there, and it will try to extract what is the most relevant document, and basically just a semantic search. And I'll just perform that in real time so that we can have the results. Then I'll also take an example, one more example. Let's wait for this query to get finished. So how I will meanwhile the query is running, I'll briefly introduce the whatever. So whenever you are searching or querying in the data, it will not only it has a different kind of extraction method, or like it has semantic search, then it has vector search, then it has a graph traversal technology, which it can use to extract the relevant information from the data. So it not relies on one but different queries. So it autonomously decides which query to use, sorry, which strategy to use to extract the data. And for over here, if you see if you see the query answer and the confidence person and the date on which the query was, but uh, I'll I'll take you through the what are the different points that are there in our extraction. So if you see in the query, I was not able to highlight, but there are there are evidence to what document it was referring to. Then what were the reasoning that it was followed. Then it was also show you the sources, like what are the entity results, like from which it was getting. Then the graph data it used to extract data. Then the vector results that were there. So it gives you the complete picture, which is not currently getting highlighted over here. Uh, this query is taking a lot of time, but today I've hosted this instance locally, which is taking a lot of it is draining my laptop. So maybe because of that, it's not working. But I'll also walk you through the different other retrieval mechanism that is there. So I've used FastAPI to develop all the APIs and OpenAI schema documentation. So this is a simple query, but you can also use Cypher queries and generate Cypher queries and generate Gremlin queries. And if you give out the exact queries, it will try to determine try to extract the exact query for Neo4j that you can use, and it will also execute that query in Neo4j and give you the results in the same UI itself over here. Then for Gremlin, I was not able to implement Gremlin, sorry, AWS Neptune into my current workflow, but yeah, that is the current, like I was planning on, but I was not able to replicate this. Then you can these are the different strategies that you can do. I'm not sure. This query is still not complete. So probably I'll pause for some time and wait for this query to get complete. Yeah. So it was able to extract this result for the query that we ran. What company is it Elon Musk found, and Elon Musk found is while that he also it was able to also find that Elon Musk did not found Tesla, it was found to different person, but it was only joined as a chairman and later became the uh, CEO. And I'll also go again in the inspect element. Like it was able to evidence what are the documents that was used to reference these data. Um, as it was there in our data and was able to reference, then it was also reasoning steps and also the sources, like what are the different entity results or graph data or vector results that you used to come to this particular set of results. And I also have a new query. I'm not sure if this will work directly or not, but let me run that query. I have it here. Just a second. is what is the relationship between Microsoft and OpenAI. Usually this, I'll again pause for a moment and wait for this grid to get complete. Okay, yeah. So it was able to extract the relationship between the Microsoft and OpenAI. Microsoft and OpenAI has a strategic partnership between this and so it was able to extract whatever the data that was there in our from the data that was there. And if I go through the, again the what kind of evidence that is had, what kind of document did you use, organized specific packaging, it was there in our document. Again, Microsoft partner with OpenAI, and what are the reasoning steps that it used, and what are the entity source or graph data that it used to extract this particular data.